Hi everyone, welcome back to GridPro. In today's video, we'll see how GridPro can be used to generate blocking for creating a structured grid for a wind tunnel. Let's take a cut plane view to visualize the geometry better. As you can see, the wind tunnel includes features like the shower head, the converging-diverging CD nozzle, the test section placed at the end of the nozzle, the diffuser, and the muffler. We will create topology for this geometry in two sections. In today's video, we'll build a two-dimensional wireframe and revolve it to capture the axisymmetric domain of the CD nozzle, test section, diffuser, and muffler. In the next video, we'll capture the shower head assembly using GridPro's whole topology generation tool. Let's get started with the 2D wireframe generation for the geometry. We'll begin by positioning the work plane at the center of the geometry with the z-axis as its normal. A 2D topology will be constructed on this work plane, which can then be revolved 360 degrees to form the complete domain. From the corner menu, select Default Work Plane to place corners directly on the work plane location. Let's start the 2D topology building process from the diffuser region. Place two corners approximately near the longitudinal axis of the wind tunnel and two corners at some distance on the top side. Link the corners to create a rectangular structure. Add vertical and horizontal inserts to capture the walls of the nozzle extension and the muffler. Remove the unwanted edges by selecting the Remove button within Edge mode. Group the corners near the end surface of the diffuser and copy them to the end surface of the muffler. Additionally, we need to copy the corners from the end section of the nozzle to a location near the showerhead assembly. We can achieve it by grouping the corners and aligning the work plane to the grouped corners using Fit 1. To make sure the work plane is along the X direction, align the work plane along the global X-axis. Now drag the work plane near the showerhead assembly and copy the corners on the work plane. Add vertical inserts to represent the varying cross-sectional area of the wind tunnel. Also add a horizontal insert to represent the cylindrical wall of the showerhead assembly. The extra corner inside the showerhead assembly can be deleted using the Remove Corner option. Positioning the corners close to the surfaces helps achieve faster grid convergence. Use Move on Screen option to move the corners close to the surfaces. Next, we will do boundary wraps to create an O-grid at convex surface regions. Group the corners representing the wall of the nozzle and do one boundary wrap with a small percentage of 0.5. Similarly, group the corners representing the muffler wall and the convex intersection of the showerhead assembly cylinder. Do a boundary wrap with minus 0.3%. This will create an O-grid at the convex features. Group the corners representing the wall of the cylinder, including the wrapped corner, and do one boundary wrap. This will create a H-grid topology at the cylinder. Nozzle assembly intersection. This way, the basic 2D topology gets created. However, the revolved topology might display a mild singular warning message at the convex intersection of the cylinder of the showerhead assembly. To avoid this, an internal surface can be created at the sharp intersection. Let's add an insert which will create a closed sheet which can be assigned to the internal surface. We will group the corners, which needs to be assigned to the internal surface, in corner group C9. As the corner group can be updated by adding the corners of the revolved sheet, it makes it easier to assign the grouped corners directly to the surface. The next part is the surface assignment. In GridPro, surface assignment tells the grid smoother where to project the grid nodes during grid generation. We can assign the 2D sheet and revolve it by 360 degrees. This reduces manual effort by retaining assignments in the revolved topology. Make the surface to which corners are being assigned as current, and drag the mouse over the corners, clicking on the Add button, to assign them to the respective surface. We need to create an analytical surface to assign the corners sitting above the showerhead. Create one plane surface by aligning the work pane to the corners. Assign the corners to the created surface. Surface assignments can be checked by clicking on Check button and making the surfaces current. Now let's revolve the 2D topology. GridPro's Revolve with Core option helps create core blocking by providing an input corner for the core. Revolve the complete 2D topology about the origin along the x-axis. We need 24 copies of the 2D sheet in the revolved topology, which can be easily merged with the showerhead topology. Group the corners placed along the longitudinal axis in C2, which will be used to generate the blocking at the core. It's advisable to keep the Update Corner Group flag on. This updates the existing corner groups by adding the corners from the revolved topology. After hitting Apply, the blocking gets generated for the complete 360-degree domain. The blocks for the core are generated automatically, which can be visualized by taking a cross-sectional sheet. We haven't assigned the topology for the diffuser surfaces yet. Group the outer corners into one corner group. Keep this group as a reference. Then select an empty corner group and add the corners which need to be copied to the top surface. Make the top surface current and copy the group corners to the top surface with links. Repeat this process for the surfaces of the other three sides of the diffuser. As you can see, the topology for the entire diffuser is now created. Now we will assign the copied corner sheets to the diffuser surfaces. This can be done using the generic option, which displays unassigned corner sheets. Make the respective surface current and assign the highlighted sheet using the Assign Multiple Corners to Current Surface button. This completes the topology for the entire axisymmetric domain. The validity check shows that the topology is valid, but the edges emerging from surface-surface interactions need support surfaces. We have already created a disc-shaped internal support surface, which we will load. A similar surface can be easily created in GridPro using the internal surface feature. The corners for assignment are already grouped under corner group C9. We will include the core corners in this group and assign them to the internal surface. To avoid very severe singularities, an internal wrap with an insert will be performed. Now the validity check shows the topology is valid with no singularities. The topology has 2,452 blocks. This way, we have created a valid topology for the axisymmetric region of the wind tunnel model. We hope this video helped you understand an efficient approach to creating the blocking for the axisymmetric region of the wind tunnel. In the following video, we will show how we can use the GridPro's hole topology feature to create the topology for the showerhead. We will also merge the topologies generated for the showerhead and the axisymmetric domain and run the grid smoother to get a high-quality grid. If you have questions, feel free to contact support@gridpro.com. Thanks for watching.